Now let us solve the example using method of sections. This is a sample problem from the book, as you can see. Calculate the force induced in members CL, KL, and CB by a 20-ton load on a cantilever truss. Now, in this particular example, we have already defined a cut section. As you can see, it is cutting through right here, cutting from element KL, CL, and CB. Also, if you look at this particular example, you have been given that there are 6 planes, that is GF, FE, ED, CD, CB, and BA. 1, 2, 3, 4, 5, 6. And each plane is of 12 feet. Also, he has provided you the dimensions of from H to F. This dimension in a vertical sense is of 16 feet, and as you move towards M, it is of 26 feet. As we know, L is right in between, so 16 to 12 will give you an average height of L of the element LB. Now we have to find the forces on the members KL, CL, and CB. We can start with, if we start with method of joints, you can start from point G. Then from point G you can go to point H, then from H, F, I, and then so on and so forth. And it is going to take a lot of time. One of the most simplest approach is using method of sections, and we need to identify a certain point where we can eliminate the maximum number of forces. So we know the forces acting on this particular joint will be along KL, along LC, and along CB. Before that, we are going to assume how forces are acting on this member. Either they are compressive forces or tensile forces. If you look at this particular example, you know the author has chosen that KL to be a compressive force, tensile force, CL to be a compressive, is going through under a immense compression, and CB is also going through a compression. CB is going through compression, KL is going through tension, and CL is going through compression. So his assumptions we're going to follow through. Then we also need to find out a certain arm length, a point which is going to eliminate maximum number of unknown. To begin with, let us start with point L, assuming sum of moment about point L is 0 for this particular section. The only two forces that are acting and perpendicular to L is this drop along here towards the force CB, and this length here at point going towards L. So we know the value of LB, that is about you can say 21 feet, and we know the length of from G to point B, that is again how many planes, 1, 2, 3, 4, 5 times 12. So we know 20 Newton, 20-ton force, 5 planes times each plane of 12 feet, moving in counterclockwise. This means it's a positive movement, and then the force CB times 21 feet has to be balanced as they are rotating about, creating a moment about point L, and hence we have found the value of CB. Similarly, we are going to find the value of KL by assuming this moment about C to be 0. Now if you look at this thing, the two forces entering C are CL and CB. Let me use the eraser and let us make things more clearer. Okay, if you take the moment about point C, the two forces that pass through this point are CB and CL, and they have no moment arm. As a result, the effect of these forces to create moment has been neutralized. The only component that can generate about C is the component of KL, that is perpendicular to this length of 61 feet, and the other component is passing straight through this force line of action. As a result, it will not generate any moment. So two forces balancing each other is this and the force created by point G balancing each other, and we have 20 times 4 planks, that is from point C is 1 2 3 4 and times 12 feet. Now where did we get 12 by 13? It is just a angle, and this angle can easily be found by calculating the point P. We know the length L. We can find this angle by 21 feet, distance between 16 and 26, and you find the value of this length, and this angle is similar to this angle, and the value of this angle will give you the ratio of projection along the x-axis, KL, and times 16 is the arm length, and hence we will find the value of KL right here. The last place to find is using point P as the center of rotation, and we have chosen point P because this particular arm length is going to neutralize the effect of KL, and this particular point is also going to neutralize the effect of CB, as they both passes through this point without any arm length. The only force component that is going to generate a moment about point P is CL. At a component of CL, if you see CL is at a certain angle, only the Y component of the CL is going to generate a moment about point P in a clockwise direction, and G a counterclockwise direction, balancing the two moments, and you can find the value of CL. Now, this is a very simple example. Let us move forward to another example, a sample problem. Now, if you look at this thing, we have to calculate the force in the member DJ of a Howe roof truss as illustrated right here. Neglect any horizontal component of the force it supports. This means A, X and GX do not exist. They are balancing each other, in fact. So we have to cut the sections in such a way that there should be no more than 3 unknown forces. But look at this particular technique. He has managed to use the first section by cutting it right here, and the second section is cutting it right here. If you look at this thing, in first section he's cutting KJ, CJ and CD, 3 sections. In the next section he's cutting KJ, CJ, DJ and DE, 4 members. So in order to solve this thing, the first thing is we're going to solve the left hand side section. From there we can find the value of KJ or CJ or either one of them, and then we can reduce the number of unknowns and we can move to the next section. As you can see, the first thing is we know the sum of moment about A is equal to 0, and to find that we have you can choose this force B, C, and if you take about E, the any force acting on the element KJ has to be neutralized. The only component of force that is going to work or create a counter moment would be through CJ, and if you look at CJ, it is also you can say a component of it is going to come into play. The other component, that is CD, is also passing through the arm length, as you can see right here. As a result, it will have no effect. The only force that is going to have effect about moment about A is CJ. And you look at this equation, we have the plank's length, the angle at which it is being projected, as we know it is a right angle triangle, and then we have the external forces acting on it, so we can find the value of CJ. But you have to remember, the value of compression and tension is being calculated in this book. The author has assumed the value. You can start by pre-assuming that the forces of your own direction of your own, and the sign will confirm or negate your assumption. So all you have to do is, don't need to go through the calculations again. All you have to do is change the sign. Now let's start with MJ, moment about J. This is going to be used to find the value of CD. Why? Because if you look at J, the force acting along Cj will be nullified about this point because there is no moment arm, and force acting on element Kj will be nullified since it also cannot provide moment arm. The only force that is going to create a reasonable moment will be the force on element Cd, which has a moment arm created by Cj, a length Cj, not a force Cj. Now, if you look at this direction, you can see uh, CD times 6. He has taken the value of CD, a component of CD right here is acting perpendicular to this thing, to the creating a moment arm of 6 meters, plus 18.33 into 12 again. This is the force that is coming from the distance of 12 meters. This will be 12, this component. Uh, 18.33 came from the reaction forces, as you can see, from the A, right? So from 18.33, and we can find the value 10 for acting at point, uh, at a distance of 4 meters, and 10 acting at a distance of 8 meters should be equal to 0, and hence we have found the value of CD. We have calculated the value of CD. Now, as you can see, the value is negative. This means our assumption to be to be in tension has been negated, and we have to change the direction, and it has fixed our assumption. Now, remember, once you have solved for the you can say defined the directions before solving, do not change the direction within the problem. Like while solving, as we have calculated that CD is calculated negative, and since it is negative, we know that it is no longer, our assumption was tension. We are not going to change this assumption for the rest of the numericals, because other assignments are based on, and our calculations numericals are based on this assumption. All we have to do is introduce the same minus C value of kilonewton, CD minus 18.63 kilonewton throughout the equations. But the final answer can be fixed that this is not tension, this compression. In the end, it has to be changed in the very end of the problem. Now, in order to find the value, now let's come back to the equation. In order to find the last unknown, that is dj, we can to find the last value of dj, we are going to jump to the second section. The section 2, if you see, we have found the two unknowns, and right here two values, that is cj. So from there, the number of 4 unknowns can be reduced to 3 unknowns, and this section has now become available to us to solve. The value of dj can be calculated by creating a moment about, by saying that the sum of moment about point G is equal to 0. No need to solve internal forces, we just solve for the external forces at joint I and the forces at the cut section of this section, at the bisection of this particular section, and will generate a corresponding equation. And here we have the equations right here, which is equal to 0. As a result, we can find the value of dj. Now you have to remember one thing: method of sections is only utilizing one particular equation. In method of joints, we were using two equations: sum of forces along x-axis equal to 0, sum of forces along y equal to 0. In method of sections, we are using the equation of moments, that the moment about a particular point is equal to 0 within the truss or outside the truss, using the forces of specific sections under consideration or external forces under consideration. The technique, as we have studied in both the section, is to calculate a proper point of rotation. A good point of rotation is a point where maximum number of forces can be, you can say, their effect can be reduced, minimized, or negated. Like here, like in previous section, And in this particular previous example, in this particular example, we have chosen certain points like moment about point A, moment point J, moment about point G, to reduce the forces of unknown reduce the forces or unknown forces as many as possible. As you know, the moment is generated by a moment arm, which is perpendicular joined by a force acting on that arm. Uh, Further, uh, this is a very basic example. Furthermore, practice of the problems provided at the end of the chapter will help you further improve your skills. I will be sharing certain other numericals soon, and if you have any other questions, feel free to contact me. Thank you.